Hello, welcome to Coach Olson Math. Today we are looking at the Pythagorean Theorem. This theorem was named after a Greek man named Pythagoras who existed about in the 500 BC range. He had kind of a secretive cult-like math group, if you can believe that. And out of this group came this theorem. Because they were so secretive, we can't be sure that Pythagoras developed this, but I think we're pretty sure that his group did. So what the Pythagorean theorem does is it relates the legs of a right triangle to its hypotenuse. Okay, only dealing with right triangles. It relates the legs to the hypotenuse. And what the theorem states is if we take the sum of the squares of the legs, so in other words, if we square both legs and add them together, it's going to equal the square of the hypotenuse. Now, what do those words or terms mean? The hypotenuse is the longest side of a right triangle. It is located directly across from the right angle, which, if you don't know, by now it's a 90-degree angle. Right triangle has one 90-degree angle, and the hypotenuse is located directly across from that angle. The legs actually form the angle. So the legs of hypotenuse come together at a 90-degree angle, and the hypotenuse is actually directly across from that. Okay, we're going to look at ways to use the Pythagorean theorem in today's lesson. In example 1, we're going to look at three triangles that are missing the length of the hypotenuse, and we're going to find those using the Pythagorean theorem. So again, we have a squared plus b squared equals c squared. Looking at this, remember the legs form the right angle. The hypotenuse is directly across from this. The hypotenuse is always c. It doesn't really matter with this formula which one is a and which one's b, and in this case they're both the same anyway. I usually go with the shortest side as being a and the longest leg as being b, but it really doesn't matter when you're using this formula. So we're going to square both of these. So I'll square 6 twice. I'm going to add those together, and that's going to give me what the square of the hypotenuse is. So if I square 6 to get 36, and that's equal to c squared, well, that added together is 72. So 72 equals c squared. Now, I don't know what c is yet until I get rid of that square. So I use an inverse operation, and the inverse operation for a square is a square root. So c is equal to the square root of 72. Now we have to simplify this. Okay, sometimes you need to get a decimal answer, sometimes you need to simplify. I think it's kind of best to simplify in most cases in algebra here, unless you're directly told to get a decimal answer. So what we're going to do is we're going to take out a perfect square that goes into that, and since I know that 2 times 36 is 72, because I did that here, 36 is the largest perfect square, so we're going to divide 72 up into 2 times 36, and we bring out the 36, leave the 2, we get 6 square root 2. 6 square root 2 is our answer, so this is actually 6 square root 2. Okay, moving on. Now notice these were the same, these are the same. We're going to get a very similar answer to this, so let's look at that. And notice here also, when these were the same, we got a number, this number here matches these. Let's see what happens here. Okay, we're going to take 12 and square it. I'm going to go ahead and, I'll just put it in the formula. We'll be patient here. Okay, so we do that. We get c squared. It gives me, started trying to draw 4. 144 plus 144 equals c squared. That means 288 equals c squared. So if I take the square root to undo that square, I get c is equal to the square root of 288. That's supposed to be an 8. I really still have trouble drawing with this pad here. Okay, so the square root of 288. I'm going to simplify that, and I happen to know that 2 times 144 is 288. I did that right here, and 144 is a perfect square. So I divide that up into 2 times 144. I bring out the 144 as a 12. I leave 2 in as the square root. Okay, and so this is 12 square root 2. Notice this was 6 square root 2. When the legs are the same, we keep that here, that same number here, and we just multiply it by the square root of 2. That actually is true for all 45, 45, 90 triangles. So if these are both the same, This is a 45-degree angle, and that's a 45-degree angle. Okay, and it works for all 45, 45, 90 triangles. But that's not what we're learning today. Just wanted to show you that. Okay, here we have one more. I'm going to say a is 9, so I'm going to do 9 squared plus 12 squared equals c squared. 9 squared is 81, 12 squared is 144, and that is equal to c squared. So we have, we're going to add these together. So we get a 5, 2, and 2. Okay, c squared equals 225. Now, I happen to know 225 is a perfect square, so if I take the square root of 225, remember, it's the positive square root. We don't deal with any negatives here in side lengths. We get 15. Wanted to do that. I did not mean to do that. Let's back that up. I don't need the square root sign. C is equal to 15. Okay, C is equal to the square root of, C squared is equal to the square root of 225. C is equal to 15. And this is inches, and I did forget to put the units in all of these. That is not good. My old math teacher, if he were alive and knew that I did that, would probably give me a call. But that is how to find the hypotenuse using the Pythagorean theorem. Looking at the second set of examples, we are looking for the lengths of legs here, not hypotenuse, legs. What we said earlier is that the two legs form the right angle. So this one's missing. If you don't see an A, B, or C, just know that the segments that form the right angle are A and B. C is opposite the right angle. Okay, so I call this B because it's the longer side. If you call it A, that's fine. Now we're going to put everything in the formula. So let's find room here. We're going to do 5 squared plus B squared, which we don't know, is equal to 13 squared. Okay, so we have 25 plus b squared is equal to 169. Yeah, okay, we can make that work. So we're going to subtract 25 from both sides, and we get b squared is equal to 144. I know that's a perfect square, so when I take the square root of that, I get 12. Okay, so B is equal to 12 meters. 12 meters. So what we did that was similar to finding the hypotenuse, we squared everything. And then we took the square root at the end. But the middle step is different in that instead of adding, we actually subtracted. That's the only thing that's different when you're finding a leg, the middle step. Okay, look at the next one. We got 26, that's directly across from the right angle. That's C. 24 is, we'll call it B, so we're looking for A. I'll put that up here. So A squared equals 24, no, didn't mean to do that. Okay, A squared plus 24 squared equals 26 squared. Okay, we're going to square everything. That is the first step, no matter what you're doing here. So we square 24, we get 576. And we square 26 and we get 676. Now, the middle step we said we subtract. So if we subtract 576 from both sides, we get, I forgot the square there, we get A squared is equal to 100. And I know 100 is a perfect square. A is then equal to 10. We take the square root. Okay, and that is 10 centimeters. Okay, one more of these. I'll say we're looking for A here. We'll put it right up here. So A squared plus 12 squared equals 15 squared. Again, first step, square everything. The middle step when we're finding a leg is to subtract. Let's see, we get, that's 1. We're going to get 81 out of that, is what it looks like. That is a perfect square, so we take the square root, we get 9. So A is equal to 9 feet. That is how you find the leg of a right triangle using the Pythagorean theorem. In example 3, we're actually going to look at side lengths and determine if those side lengths form a right triangle. again, using the Pythagorean Theorem. So what we have to do, and we're going to definitely want a calculator for at least one of these, maybe two, we'll see. What we need to do, we're not really concerned with units here like inches, we just are concerned with the side lengths. Okay, so we square all of them. We're going to get 36 here. 24 is 576. We did that a while ago. Now, when you square something like this, you think of it as two separate things. If I'm doing this without a calculator, I'll square the square root of 2 and I'll square 18 and then multiply them together. So square root of 2 squared is just 2. So whatever 18 squared is, I'm just going to double it. Okay? So again, just to show you, it looks like this. We're just splitting it up. And when I square a square root, it just it's an inverse operation. So you just get what's inside. So 18 squared is 324. 324 times 2 is 648. 648. So what I have to do is C. Now this is C. We're calling this A and B, okay, and this is C. So we've squared them. So if A squared plus B squared equals C squared, then it is a right triangle. If this does not equal this, then it's not, okay? It's one or the other. And I can see very quickly, 6 plus 6 gives me a 12. It ends in a 2, not an 8. So this does not equal this. So we're going to say this is not a right triangle. And I'm abbreviating so you don't have to see my messy handwriting. It's messy enough. If I start trying to spell all that out, it will be really bad. Okay, so next, again, we're doing that with all 5 of these. We're going to square. Again, I'm not concerned about these units. Okay, so I'm going to square this, 16. Now remember, I square each of these separately and then multiply them together. So that's really 16 times 3 when I square everything. And that's going to be 48. And this is 64. So does 16 plus 48 equal 64? And the answer is definitely yes. Definitely yes. And so it is a right triangle because A squared plus B squared equals C squared. Okay, for this one, we've got, if we square both of these separately, we get 25 times 3, which is 75. That one's easy. This is 64, and this is 100. Okay, and again, it does. I know this is this is shorter than this, but again, it's just A squared plus B squared. This is definitely C. So do these added together equal this? And the answer is definitely no. So it is not a right triangle. Okay. With this one, we have 64. If we square this, 16 squared is 256. 256. 12 squared and square root of 2 squared, we get 144 times 2. That's 288. 288. Again, 144 is 12 squared. Square root of 2 squared is 2. 144 times 2, 288. Well, it's easy to see. This 6 plus 4 gives me a number that ends in 0, not a number that ends in 8. So that's not equal. We will say no. I'm not going to spell that out. Not a right triangle. Okay. This one we're going to need a little help on, or at least I will. You may not, but I will. 9 squared is 81. 81 times 5. Okay, so we square that, we get 81. We square that, we get 5. Okay, so when we multiply those together, we get 405. 5 times 8 is 40. 5 times 1 is 5. 405. Okay, now I'm going to need some help squaring 47. Definitely. And we're going to get, with that, 2209. Wow, I don't know what just happened. No, stop. Okay, let me back up. That was crazy. Okay, try this again. Old man in technology. Okay, let's see. Am I drawing? Yeah. 2209 is what I get here. Now let me try 52 squared. I get 2704. Okay, now the question is this plus this equal to this? Well, if we do that in our calculators, I get 2209. So 2209 plus 405, I get 2614. What I did the first time is I subtracted these, and I did not get this. So you just add them this way, you get 2614. 2614 does not equal 2,704. So this is not a right triangle. And that is the end of the example 3 set. Let's look at a couple of word problems having to do with Pythagorean theorem. Okay, the first one, it says a door's height is 4 times its width, W. What is the maximum length of a painting that fits through the door? Well, before we think this is really difficult, again, we're just kind of forming a right triangle. So let's draw our little door here. Okay, and the painting is kind of going to go in this way. I'll kind of do a little bit of a dashed line. Okay, you carry it in as at an angle. Okay, the width of the door is W. The height of the door is 4 times its width, so it's 4W. Okay, so we're finding C. So I'm going to square. Actually, I put B first, it didn't matter. Okay, I'm squaring that. I'm squaring that. And that's going to give me C squared. Okay, this gives me 16W squared plus W squared. That equals C squared. Add like terms, I get 17W squared equals C squared. Take the square root. Well, if I take the square root, I get this, 17W squared. I'm going to pull the W out. It's a perfect square. So my answer is W square root 17. W square root 17. So in other words, if we know the width of this door, we multiply it by the square root of 17, and that's going to give me the maximum length of a painting that can fit through that door. Okay, let's clear this and let's go to another one that a little more in depth. Looking at this equilateral triangle. Now, equilateral means all the sides are equal. So we got this, okay, and that's equal to this side. Okay, so this is 240 over here. This is 240 over here, and we will probably certainly need to know that, and probably need a calculator here. So a garden is in the shape of an equilateral triangle, obviously a mathematician's garden, because no one else would do that, maybe. The gardener wants to cover the garden with a depth of 3 inches of topsoil. Okay, so we've got depth. So we're going to have area and depth. That's going to give us volume. Okay, so we're going to need something in cubic inches for volume. Okay, so we have to find the area of this and multiply it by the depth. That will give us the volume of topsoil that is needed for this equilateral triangle. Okay, so to find the area of a triangle first, it's base times height divided by 2. Well, we know the base is 240. We just don't know the height yet. So we've got to find the height here using, of course, Pythagorean theorem. Okay, so to do that, we need to find this height right here. Well, I can't use 240 on the bottom. That's the entire length. What I need is the length of this leg here. That actually forms the right angle. That's actually 120. This actually bisects this side when it's equilateral triangle. That's an angle bisector. So we get 120 for this leg. We get 240 for the hypotenuse, and we're going to do some squaring and subtracting. This is we're calling this B. This is A. This is C. So 120 squared plus B squared equals 240 squared. Definitely want a calculator for this. Okay, 120 x squared, let's see, that gives us 14,400. Okay, we don't know what B is. Okay, 240 squared, 57,600. Now we're going to subtract. And when we subtract this from this, we get B squared is equal to 43,200. Since we are finding a measurement of earth needed, we don't want a simplified square root. We actually want a decimal here, and we'll round it. Okay, so we're going to take the square root of 43,200, and we're going to round that thing. I get 207.8, so we'll make that 208. So B is equal to 208. Okay, that is the height of this triangle. Okay, so remember it's base times height divided by 2. Here's the base, 240, height, 208 divided by 2. Okay, so again, 240, and glad to have a calculator, times 208 divided by 2. We get an area of 24,960 square inches. Okay, now if we want cubic inches, we've got to multiply it by the depth. This is just the area, surface area here. So we need to multiply it by 3. And that gives us a volume of 74,880 cubic inches. 74,880 cubic inches. And that sums up the Pythagorean theorem.